Okay, we're back. We hope we don't have as alarming a class this time as we did last time. That was a joke. Alarming, alarm. I got a few titters. All right. Let's go to the PowerPoint by way of remembering what happened last time. We talked about kinds of evidence that are not acceptable, and we talked about then, just because everybody says it's so, or because experts or everybody believes it's so, doesn't make it evidence. We also talked about unacceptable explanations, and basically this boiled down to saying that you have to use proper logic in order to reach good conclusions. And we gave some examples of that. So logical fallacies. Here we go. That you have to be careful not to draw conclusions. Here we gave some examples that are not. The second one, of course, is part of the original rationale behind dyslexia. Oh, all dyslexic kids who can't read must have brain damage. Okay? Come back to me for a second. Let me again emphasize that you have to be very, very, very careful about circular explanations. They're very tempting, okay? And especially if you use fancy words. There are certain key words that can give you an idea that it's a circular explanation. The word syndrome, chronic fatigue syndrome, which means there's a bunch of things we see, but we don't know. Nobody, if we take the woman that we were talking about last time, and she comes in, right, and they test her blood iron, and she's very anemic, nobody's going to say to her, oh, you have, right, you have chronic fatigue syndrome. They'll say, you have anemia. Nobody's going to say, oh, you have, or if it turns out that she has thyroid problems, nobody's going to say, you have chronic secretion syndromes. They'll say, you have a deficient thyroid. Syndrome means a whole bunch of symptoms that we see, we really don't know why. But also, words that have words like disorder. You see that on you see it on the television. They're advertising this disorder, and this will cure the symptoms. When you have a disorder, right? Nobody has. If somebody has a brain tumor, you don't say you have a neurological disorder. You say you have a brain tumor, right? If someone seems to be having seizures and they can't find out what it is, they call it a disorder, right? The word "dis" by itself, this, that, this, the other. We'll talk about that. Is a sign that you really probably have what you have is a circular explanation, repeating what the symptoms are with fancy language. Now, the next thing we need to talk about, let's go to the PowerPoint for 1 second, is data and theory. Okay, off the PowerPoint. Okay, data and theory. The question is the relationship to data and theory. Okay, we talked last time about information. Didn't we talk here about someone with a bottle of water? That was here, wasn't it? How close it is, right? The question becomes, how do you, where's your bottle of water? Weren't you the one with the bottle of water? Who had the bottle of water? Where is it? Okay, you forgot it, okay. The question becomes, how do we decide what's important to know and what's not important to know? How do we decide what kind of information we want? Okay, we're going to take a vote here, for instance. We're going to take a vote. For instance, how many people here think that it's very important to investigate ways to motivate people to learn? Who thinks that's important? Raise your hand. How do we get people to be motivated? You don't think so? How many people think it's not important? Just me? I don't think it's important. That's because of the theory I come from. Okay? I think people are naturally motivated to learn. I think it's important to investigate what turned off people who don't want to learn something. Okay? So the question of, and I would never investigate what are ways to motivate kids. It's ridiculous to me. Well, I won't, I'll just say that for now, right? That's not exactly true, but say that for now. How many people think that it's important for teachers, that one of the most important things teachers can do is to plan for the year and set the goals that they have for the year and set the material they're going to teach for the year, or at least for the next several months? Who think that that's important, to be organized like that and plan ahead? Just about everybody. Who thinks that that's a terrible way to do education? Okay? Just me. Again, I'm one of them. I wouldn't say terrible, but you see we have differences of opinion. Well, all those things make a difference in what you're going to investigate. The people who voted no are going to say, I'm not very interested in taking a course in goal setting, right? Who said no? Why no? Who said no? Why no? Push the button down. Yeah, it's working. Go ahead. Push it down. You got to keep it hold. You got to hold it down while you talk.
I said no because teachers, they don't always follow the lesson plan, and classes very dependent on the type of students and their class.
So here's one person who says, "Wait a minute. How can you set a lesson plan for kids you haven't seen before? Shouldn't you be responsive to where the students are and what's going on?" That's pretty good. A guy named Goodman said that a lot of years ago. That's very good. Go ahead, next.
I think there's a difference between setting a lesson plan and modifying it according to where your students are at the time, than going in there without absolutely any goals and not knowing what you want to teach the children.
Okay, that's interesting. Is there anyone here who thinks that in, let's say, a regular classroom, you have 20 kids, that in March you may be teaching something that would be legitimate to be teaching something that never even occurred to you when you walked in there at the end of August? That you will be teaching something in March that never even occurred to you when you first walked into that class in August? Go ahead. Yeah, go ahead. Why? How do you figure that? Push the button down. Keep hold it on while you're talking.
Because as you get to know the children, you'll find out what their needs are and what they have learned and what they haven't learned, where they're at.
Right. Anyone else have a different reason why? Go ahead.
Well, things come up, like things that are in the popular media at the time, like when Katrina came around, a lot of the kids that I worked with were very interested in why hurricanes happen, and is a hurricane going to come to Houston? And I mean, just things that you wouldn't maybe normally talk about.
Things come up. What if the kids are interested in something else? Is it legitimate to say, never mind what I wrote down. I want to talk about the things that came up, things that interest the kids. Okay? Some people agree with that, some people don't. Go ahead.
I think it's interesting that the lesson plans, they may not be something you follow, but they do give you a starting point. You have to have some place to start from.
Okay. Some people will say, I don't even think about lesson plans. I go in and find out what interests the kids. Some people say, look, I don't agree with that. I got certain things I want to teach, that's what I want to do. And some people in the middle, the way you are, and say, look, I got to have a starting point, and then I'm ready to deviate. All those things come from different approaches to what education is, what it means, what it should do. Okay? So, usually I take a vote, but the heck with it. Okay, so we've been talking about, let's go back to the PowerPoint. We've been talking about data, evidence, observation, facts. Data are the evidence, data are, right? Data are the evidence, the observation, the facts, gathered by scientists using the scientific method. Okay? But the question is then, what's a theory? A theory is an explanation of the facts. It attempts to explain why the world is the way it is. Why we observe what we observe. Okay, let me give you an example, all right? Did we talk about the gravity here? Did we take the vote about gravity? Yes. Good. Okay, come back to me. So in other words, the theory Gravity is a theory. It's a mathematical formula. Remember, I wrote it on here and messed it all up. Okay? Gravity is a theory that tells us, look, this mathematical formulation tells me why the pen falls and why it falls as fast as it does. Okay? And a theory is an attempt to explain why we observe what we observe. Do we take a vote on the solar system? How many of you people believe that how many of you believe that we're living, that the planets and the sun are a solar system, and the planets go around the sun, and the sun is basically motionless relative to the planets? Who believes that? Who believes that? How many people believe that the Earth is in the center and the planets and the sun is and the moon and the planets are going around the Earth? Okay, not too many people. You don't think the Earth is going around the sun? Push it down, push it down, push it down.
I believe in many theories. I believe that if the sun interacts with the Earth, and if the Earth interacts with the sun, why can't they evolve around each other?
All right. I'm going to show the rest of you that the Earth cannot possibly be moving. I'm going to show you that the Earth cannot possibly be moving. Okay? I'm going to make you a model of the solar system, a theory. Okay? Whoops. A theory is kind of a model that explains, in case of mathematical model. I'm going to make you a model and show you that by the observations that we have of the stars and the sun and the moon and the planets, the Earth cannot possibly be moving. First, we have to establish one thing. The positions of the stars in the sky never change relative to one another, right? The constellations stay the way they are. You don't see a star, except for the planets, but you don't see the Big Dipper. All of a sudden, there's a star missing from the Big Dipper, then it comes back 6 months later. Stars don't switch positions in the sky, right? They remain the same. Right? That's a clear observation. You all agree with that? That observation is proof positive that the Earth is not moving. And I'm going to show it to you. Who's over 6 foot tall? Who's over 6 feet tall? Good. Can we do it over here? Come stand over here. Who's under 5'3"? All right, come over here. Who's wearing blue? You're wearing blue. You come over here. You're not over 6 feet tall?
I'm 6.
Oh, he's 6. Okay. Why did I pick blue? There used to be a show on educational TV, Big Blue Marble. The Earth's a big blue marble when it's seen from way out there. The sun and moon declare a beauty that is rare. Don't worry, there's no charge for concerts. Okay. Then I need a sun who's wearing yellow. It's not my fault. I didn't tell you to wear yellow. And then I need, just stand up here. I need another star. Okay, here we go. This is the sun. Okay, can we see this? You have enough? Get this sun, stand over here. Don't move. Okay, move over a little bit to the left and then don't move. Okay. Who's the Earth? Okay, Earth, you come stand over here. Now here are the stars. I'm going to put 3 stars in the sky. Okay, come over here, stars. Put 3 stars in the sky. You're both under 5'4". Okay, I'm in good shape here. Okay, you stand in the front. Okay, come over here. Come stand over here. Can we see over here? This will be better. Not you. Oh. You stand over there. Move over. No, you stand over here. Tell me your name.
Rosanna.
Wait. Rosanna?
Alexis.
Alexis?
Adam.
Adam. Okay, we got 3 stars here. Okay. Let's see if I can. Wait. Okay, these are the 3 stars in the sky. I changed my mind. Rosanna, come stand over here. Can you see her over there on the screen? Yeah, good. Okay. Okay, we're in good shape. Okay, don't move. Okay, Earth, come stand over here. Earth, tell us your name.
Hugo.
Hugo. Should have made Adam the Earth, right? Okay, Hugo, come stand over here. Okay, he's the Earth. He's the Earth. Okay, you see he's the Earth? Okay, Hugo, turn around and look at the stars. Turn around and look at the stars. Tell me how many stars you see.
3.
3. Which one's in the middle of the other 2? Wait. How many stars do you see?
3.
Which one's in the middle of the other 2?
Adam.
Adam. Okay, start going around the sun. Go around the sun. Go. How many do you see?
3.
No, you don't. Stand right over here. Stand right over here. Adam, stand this way. Move over a little to this side, where you were before. How many do you see?
2.
2! Over here. Come stand over here. How many do you see?
3.
Okay, now keep going. Stop. Okay, how many do you see?
2.
2. Okay. One star disappeared because he's moving. That's called a parallax effect. If I move over a little bit this way. You move over a little bit this way. Okay. Now I can't get it right. Okay. I don't have enough room to show it. If I stand over here, move over there. Okay. Over here, you see, come over here. Right there. How many do you see now where you are? 3. Then if you move over here, you see 2. See, if I could move Rosanna back far enough, which I can't because she'll be out of the camera, eventually, if he made his network, if he could come out here he would see, let's make his circle wider. How many do you see now?
3.
3, and which one's in the middle? Rosanna's in the middle now, right?
Yes.
Rosanna's in the middle. You see what I'm saying? As he moves, okay, now Rosanna disappears over here. Come over here. Now you see that Rosanna's disappeared, right?
Yes, sir.
Now, come back here. Now how many do you see?
3.
And who's in the middle?
Adam.
Adam. Okay, so what happens is that the Rosanna star starts out in the middle of the other 2. Okay? Then as he moves here, it disappears. And as he moves here, it pops up again, but it's to the left of this one. Or, to put it differently, this star would appear to be going like this. Back and forth, back and forth. First it's over here, then it moves behind him, then it's here. Right? That's how it would appear to be going. Okay, by the way, this is only 3 dimensions. If I hung people on the ceiling and dropped people through the floor, it would get even worse. Okay? Everything would be cockeyed. That's a parallax effect. Okay? When we look at the stars, we see no parallax effect. There's none. There's no parallax effect. Here's a model of the solar system with the stars in the sky, and the model shows that as the Earth moves, there are different, he sees the Earth different. The stars seem to jump around the sky. But they don't. So this model doesn't explain the data. A good model or theory has to explain the data. And it doesn't. So either you're going to have to go into class, and the first thing you're going to say to your kids when your teachers is, you're going to learn about the solar system, it's a bunch of baloney, right? Or you're going to have to modify the model, okay? Now I drew a model of what people are saying. You're either going to, can somebody tell me what's wrong with this model? If you can't, then you're going to have to give up on the solar system. Go ahead, tell me your name. Becky, go ahead.
The sun and the earth are too close to the stars. If you move them over here, you wouldn't see as much of the parallax effect.
Oh, so she's saying the sun and the earth are too close to the stars. If this, let's say when he's out here, okay, when he's out here, move just a little bit this way, okay, seeing the Rosanna star in the middle, okay, if this is 90, how far is the earth from the sun? 90 million miles, 93 million miles? To keep this in scale, where would the 3 of them have to be standing? If this is 93 million miles, and let's say Adam is the nearest star to the sun, how far away would he have to be standing? Push it down, Becky?
You'd have to be like in the next building over.
In the next building? I don't think so. I think you'd have to be on the moon, right? Far away. That's trillions and trillions of miles, right? I mean, she's right. If I took the three of them and put them in the other corner of the room and had him go around, he wouldn't see any difference. Okay, let's give them a big hand. Very good job. Thank you very much. Okay. As a matter of fact, who cannot wink both eyes? Who can't wink both eyes? You know, wink one then the other. Only one. That's amazing. Yeah, that seems to be gene linked. Almost all men can do it, and some women can't. It's like color blindness. Almost everybody who's colorblind is a male, right? Anyway, if you can wink both eyes, sorry. If you can wink both eyes, hold your finger right in front of your nose and wink your one eye then the other. You see how far it's moving? Because first you're looking from this side, then from that side. And then as you go, keep winking and move it farther and farther away. You see how it seems to be moving less and less from side to side? See what I'm saying? That, by the way, is an experiment that early physicists did. Okay, early. They said the parallax is less as you go farther away. So ultimately, this was one of the hints. The Copernicus astronomers, the astronomers who said, no, it's the sun, it's the Earth that's moving around the sun, had to say, those stars must be really far away, farther away than most people thought. There is a parallax effect, but it's so small. One of the first things they did with the Mount Palomar telescope, when they got the telescope up in California and they got it high up and they could use it, is they looked for a parallax effect. And they took some stars and they kept one spot in the sky and they kept photographing it all over the time. And then they took out these fine calibrated measurements, and sure enough, on the film, one star moved, I don't know, 1/1000th of an inch or something, that kind of stuff. So it's too small to see with the human eye, but it's there. So sometimes when you make observations, you either have to throw out your model or modify your model. How did you know about parallax? How did you know about parallax? Push that down.
I'm a space nerd.
You're a what?
I'm a space nerd.
A space nerd. Good, yeah. I mean, if you get things that are trillions and trillions of miles away, you're not going to get much of a parallax in a circle of 180 million miles, where the circumference is, not the circumference, the diameter is 186 million miles or whatever it is. It's nothing. Okay? It's like trying to get a parallax effect by moving from here to here. I'm not going to get it. In any case, you get the point. This is the thing. No one's ever seen the planets going around the sun. We've never been able to get any object outside of the solar system. They just launched something. That's, I don't know. I said just. Who knows if this tape runs 20 years, it will be launched. But they launched something that is trying to get to the outer planets. But we've never been outside the solar system. Okay? So in the end, what you have are, here, let's go back to the PowerPoint. You have a theory is a model. It's an explanation that attempts to explain the why of the observations. Okay? And so data tests the theories, okay? A theory is a model of part of the world. And it can provide support for a theory by confirming the theory's prediction and supporting the model. Or, wait, I got to show you that. That's one of my best effects. Wait a minute. I can't do it with a stupid mouse. Or, like that effect? Or, data can require us to modify or discard a theory, modify or discard its underlying assumptions because the data don't confirm the theory's predictions. I'll give you an example. Come back to me for a second. When Copernicus first put out his theory that the Earth was in the center, the sun was in the center, he assumed that the planets were going around the sun in circles. He was still taken by the idea that God made the world in perfect circles. The circle is the perfect form, and God made the world in perfect circles. But when they measured, it didn't work. The planets weren't where they were supposed to be. The sun and the moon appear to go around the Earth, and for all effects of a circle, right? It's exactly 24 hours and some seconds, or whatever it is, right? The moon is the month of the moon, but the planets wouldn't behave. So finally Kepler came along and said, I don't think this is right. He said, I think that the planets, and he piddled and fiddled, and he said, I think that the planets go around in elliptical orbits. If you think it's an ellipse instead of a perfect circle, right here, let's go to this thing. Okay, here's the sun. If the planets, instead of going around in a circle, if the planets go around in ellipses, I don't know if they're that exaggerated, this explains it better. And so, often people, come back to me, people will often call this the Copernicus-Kepler theory, not just the Copernicus theory, right? So theories are what we use to explain things, okay? Let's go back to the PowerPoint. In other words, if the evidence doesn't support what you believe, you ought to change your mind. Okay, you ought to change your mind. Or if you don't have evidence, you ought to change your mind. If you're going to say, I believe that so-and-so is true, without, right? First of all, if you don't have evidence, if you have a theory and you go to gather evidence, it turns out, I have a theory, kids who can't read have something wrong with them. And you go out and you find a lot of kids who can't read or don't have something wrong with them. You might say, well, this theory may apply to some kids, but not to other kids. Okay? If you have a theory that phonics is the best way to teach reading, then you use phonics and some kids can't learn how to read. Probably ought to think it through again. Or if you have a theory that says whole words is the best way to read, or language experience is the best way to read, and some kids don't learn how to read, you got to rethink what's going on. You might have to say, well, for some kids it's this, for some you have to rethink it, right? Educational theories should be based upon evidence, namely on psychology. They shouldn't be based on faith. Okay? Let's go back to the PowerPoint. And phooey. Wait a minute. Wait a second. Come back to me. I'm having troubles here. As people may have noticed. Okay? Likewise, let's go, now we can go back to the PowerPoint. Theories, that's because I'm using this mouse. The mouse drives me crazy. Oh, I need it for this. Theories explain data. Okay? Theories attempt to present a coherent picture of the universe. A theory is a model of part of the universe. Okay? In physics, we have theories, Newton's theory and now Einstein's theory, which attempt to be a model of the whole universe. Okay? Now, come back to me for a second. The question then becomes, what does all of this have to do with psychology? So stay on me, okay? The answer is, we have theories in psychology too. And now, I don't have this on the PowerPoint slide, but you need to remember this, okay? I have something awful to tell you. You can't get everything from data. You can't get everything from data. Go ahead. Can't hear me? I usually yell. Okay, you can't get everything from data. I hate to tell you that horrible fact, but even though science says you have to prove it to me, you have to prove it to me, you have to prove it to me with evidence, you can't prove something from nothing. Let me give you an example. How many people took plane geometry in high school? Who didn't? Oh, are you lucky. How come you didn't take plane geometry? Push that down. You stopped with algebra?
I didn't take algebra in high school.
You didn't?
No.
How'd you pass? How did they let you out?
I dropped out of high school.
Throw him out of here. You dropped out of high school? So how are you here now? This is very interesting.
I took my GED and joined the Army.
Joined the Army. You know, in the old days, community colleges didn't require you to have a high school diploma. We had one guy, we graduated with a doctorate, who didn't have a high school diploma. Dropped out in 10th grade, went to the Army, then went to community college, got all A's, and he went to he finished a degree, then he got a master's degree, then he got his doctorate with us. So, yeah. You have to know some geometry to get a GED, though. Okay, most of you took plane geometry. Did anybody take plane geometry twice? Watch this wise guy. 2 of us. Anybody take it 3 times? You're kidding me. I thought I thought I was the only person in the world.
4 times?
4 times, really? I must tell you, by the way, he's going to be a good teacher. He's persistent. Okay? I passed it all 3 times, though.
Algebra 2?
Push it down. Push it down.
Algebra 2 times.
Yeah. You passed it, though, didn't you?
Oh, yeah.
Good for him. All right, way to go. He said yes, so he didn't have them. All right. You all eventually passed plane geometry with a few exceptions? Okay. If you remember, plane geometry is proofs. Proofs. By the way, math is not really a science, because math doesn't care about gathering data. Scientists use math. For instance, for years, scientists and engineers and architects used plane geometry to build things on the earth and to build buildings and this and that. And then somebody finally came along, I mean, even the time of the Romans, they were more or less, and somebody came along and said, you know what? The earth is not a plane. It's round. So the people doing plane geometry said, I don't care, don't bother me, I'm just doing theoretical math. Right? But geometry gives us a good idea about proofs. You have to prove everything, but you can't prove something from nothing. So you had to start with the 10 basic theorems or axioms. You all passed, huh? Who got a B or higher? Oh yeah? Gee, a lot of you. Okay, tell me the 10 basic theorems. Tell me one. The 10 basic assumptions, not theorems, assumptions. Or the axioms, the things you don't prove, they're just there. First of all, if you do plane geometry, what's just there? The plane is just there. You don't have to prove you don't have to prove a plane, it's just there. It has to be. What else is just there? What? Push it down.
A point?
A point. How come the guy who didn't take plane geometry is the only one who knows the answer? A point's just there. A line is just there. Some people say, no, a line's a moving point. But anyway, you get the... Okay, and then once those things are just there, you just assume them. Okay? Then what are some of the 10 basic axioms? See, it's very, very important to teach geometry and for everybody to pass it. So by the time they go to college, nobody remembers anything. You got to think about whether teaching stuff is what education ought to be about. Okay, who remembers? I'll give you one. Parallel lines never cross. You don't prove that, you just assume that. Who's got another one? I remember one other. Then I'm stuck. Go ahead.
Opposite angles are equal.
When 2 lines intersect, opposite angles are equal. You took the other one that I remembered. No, I remember one more. Who's got another one? One and only one line can be drawn between any 2 points. I believe there's a geometry, don't quote me on this, that says more than one line can be drawn between 2 points. It's a 3D geometry. And I think it's Boolean geometry, but don't quote me on that either. I'm not sure if it's true. That's an assumption you make. Right there, 10 basic assumptions. There's also something about I think you can either assume 360 degrees in a circle and prove stuff about right angles, or assume stuff about right angles and prove something in the 360 degrees and prove something about a circle, stuff like that. You can't prove something from nothing. Scientists do the same thing. Physics, our most advanced science. Hold up your left hands, or your right hand if you're a lefty. Oh, there you go. What is that? Turn it off. Tell me your name. Push it down. Push it down.
Deneen.
Say it again.
Deneen.
Deneen. Hold up your left hand and let's see it. Can you get her left hand on the camera? Where's her? Can you get to her? There it is. Deneen. What's that thing on your left wrist there? On your...
A watch.
A watch. What does it do?
Tell time.
Tells time? What's time?
It's a little bit based on our life. So.
What? What's time? Somebody help her out. What's time?
It's a measurement.
Of what? I can tell you, if you ask me what's a yard, I can tell you it's a measurement of length. What does it measure? Measurement of what?
No, it's an measurement.
It's not a measurement. She's telling me that the watch is a measurement of time. That's what she just told me. So what's it? What's time?
It's measuring the rotation of the Earth around its axis.
It's a measure of the rotation of the Earth on its axis?
Yeah, like you know how it moves.
Keep your finger. The Earth moves on its axis, right?
Yeah, so in that way.
But you can tell me how long it takes, right? By telling me how much time.
Yeah.
But what's time? What's time? You're telling me time's a measurement of, but what is it? That's right. There you all got the right answer. There's no definition of time. Time is just something they assume. Time is just there. Right? What do scientists tell me? This table is made up of matter, right? What's matter? Some people, matter is particles. Good. What? Go ahead. Who has an answer?
Anything that occupies space.
Anything that occupies space. Yeah, what space? It's just there. It's interesting. Anything that occupies space, that's an interesting definition, right? It's particles. Okay. Time, space, matter, energy, they're just assumed by science. Okay, you got to assume something. Okay? And then there are rules. For instance, Newton came along and said you have to assume that for every action there's an equal opposite and reaction. I'm going to assume conservation of matter. I'm going to assume, by the way, which Einstein says is not true. Here. Let me show you. Come to this. What do you call this thing? The tablet? Einstein said, no, I think Newton was wrong. E equals mc squared. This is a formula for turning matter into energy. Okay? Get the matter, multiply by the speed of light squared, and that's how much energy you get. This is a very big number. That's why a little piece of uranium gives you a very big bang. Okay, come back to me. So, we just do that. We have to make assumptions. Okay? We just have to make assumptions. Okay? Now, what happened, let me give you an idea in physics, okay? For a long time, physicists made the assumption, can you see this here? We'll put it here. You can see this, right? Here we go. Physicists made the assumption that rest was the natural state of the world. Okay? Things at rest stayed at rest, and if something acted on something, things in motion came to rest. You saw that, right? It's in motion, and it comes to rest. That was just an assumption. Along comes Galileo. He said, I don't think so. Galileo took a marble, and he took it in a track, and he rolled it along the track. And it kept rolling and rolling and rolling until it fell off the end of the track. So he said, if something hadn't stopped it, naming the track ending, it would have rolled forever. If the track went off, it would have rolled forever. Then he took a smooth stone, and he went to northern Italy where it's cold, and he put it on a lake, and he pushed it across the ice on the lake. And it kept going and going to the other side of the lake. He said it was finally stopped by the water running, the ice running out and hitting the shore. He said, but if the ice had gone on forever, the stone would have gone on forever. That wasn't quite right. But he said, I think that's wrong. He said, I think things at rest stay at rest unless something acts on them to push them, to make them move. And things in motion tend to stay in motion unless something acts on them to make them stop. This was a fundamentally different, and it brought up a question. What question does Galileo, watch me, does Galileo have to answer What question comes up, what research comes up for Galileo that he has to answer, or people who follow him have to answer, that other people don't, that the other people don't? Say it, push it down.
What's the force acting on the object to slow it down?
Yeah, what made it stop? So if I ask the first people, the pre-Galileo physicists, they say, what do you need, new batteries for your hearing aids? I just told you, everything comes to rest. There's nothing to investigate. If you say to Galileo, look, I don't see anybody touching the pen, I don't think anything happening to the pen, why did it stop? He and his followers are going to have to give an answer. And of course we come up with friction, right, friction. So the kinds of assumptions you make determine what's interesting to investigate. That's why nobody cares how far Rosanna's water is from the edge of the desk, because it doesn't answer any interesting questions, right? Unless somebody says Rosanna has an anal compulsive personality, and I have measured, and she always puts her water 2.367 inches from the edge of the desk. Now I've given her a medicine that I think will stop some of these debilitating anal compulsive syndrome behaviors. Let's take some measures to see whether some of her more mundane day-to-day activities that nobody would care about otherwise, and she's compulsive about, are going away. And then I find out that she just seems to put the water down, and one day it's 2.3, and one day it's 3, and I say, oh, now I'm interested. The medicine seems to be working at least for that activity, and maybe that's a sign that other, meaningless activities to other people, which she was compulsive about. Anybody ever watched the television series Monk? How his chairs always have to be exactly this far apart, right? Then it's interesting to me, because it's in the context of a scientific question. Does this medicine work? Right? You understand what I'm saying? So you don't gather data off of nothing. You gather it off of theory. And by the way, before I start pumping her full of medicine, I ought to have a theory about why it works and what it'll do to her nervous system. Because if somebody says, well, this medicine will stop her anal compulsive syndrome, but there's also a pretty good chance that she won't be able to talk anymore, or that her left eye will fall out, right? Then I probably say I better not give her the medicine. I ought to have an idea what's going to happen, what's going on. And of course the FDA and others are very interested in looking at this stuff. Okay? And by the way, there was a medicine called Thalidomide, which was a
morning sickness.
Was it for morning sickness? I thought it was. It was in the field of things that relax you. What are those called? Sedatives. But it was, push it down. Right?
Treated morning sickness.
It was treating morning sickness in pregnant women. And it was given in Europe. And the head of the FDA, I can't remember her name at the time, this was in the 60s, she had a suspicion, was more than just there aren't enough trials, based upon how it worked and her understanding of theories of infant development, that it could screw things up. And it did. It messed up the limbs of infants. And they were either born without arms and legs, or some were born without hands. I mean, it really messed them up badly. Some were born without fingers, and it was bad. And she had a suspicion, based upon her theory of how the stuff worked, that it didn't work. And people were yelling at her, screaming at her. She saved thousands and thousands of babies. By the way, there was a real disaster in Europe. They used to be called thalidomide babies, right? People would write and say, I have a disability, a handicap. You're not supposed to use that word anymore, but based on thalidomide, there was a term for them, thalidomide babies, and it was based on theory. So all of this, she just said, I just don't like the chemical composition. It seems to me it'll have certain kinds of negative effects. She may have been wrong, but in this case, she said, there's got to be more testing. In the end, she didn't have to do more tests. They didn't have to do more testing on animals or anything in the United States, because in Europe, you begin to have all these kids who were born with these, with their limbs deformed. In any case, you get the point, okay? we have to make assumptions, and the assumptions tell us what to do. So, for instance, let's go back to the PowerPoint. Psychological theories present models of thinking, behavior, and emotions. Okay? And every theory begins with underlying assumptions that shape its explanations and guide research. Because, as I said, you have to start somewhere before you can start researching. So, come back to me. Okay, let's leave it up for a second. So, for instance, there are some psychologists who will tell you that the key to understanding psychology is understanding how people behave. Come back to me now. Is how people behave. And therefore, they're going to do a lot of research that measures what? Measures what? Say it louder so you can hear. Behavior. What changes behavior, etc. There are some psychologists who are going to say, I don't think so. There can be a lot of reasons why people engage in a certain behavior. Okay? I've got to investigate the underlying causes of the behavior. Some people are going to say, I've got to investigate. Behavior comes from thinking. I'm going to see what thoughts led to this behavior. Other psychologists are going to say, that's maybe okay, but I'm going to investigate emotions that led to this behavior. So some psychologists are going to tell you psychology is a behavioral science. Others will tell you you don't know one thing. Once you measure behavior, you don't know anything until you know what caused the behavior. Okay? So let's go back to the PowerPoint. So as I said, every theory begins with these assumptions. You have to start somewhere before you can start researching. And, there's the and, all right? These differing assumptions about people have a profound effect on the kinds of research psychologists do and on the educational practices they advocate. Okay? Come back to me for a second. Not for a second, for a little while. Okay. Educational practice ought to reflect theory, and I'll tell you why. Okay? If I say, I think it's important to give kids homework to do, okay, I have to ask you why. And then your why ought to reflect to me what you're trying to accomplish and why you think homework will accomplish it. In other words, I'm going to go and, tell me your name?
Jennifer.
Jennifer. I want to teach Jennifer the multiplication tables. And I'm going to go home and I'm going to say to Jennifer, here are all the multiplication tables. You have a week to work to do them. Now I'm going to have you say them to me, and every time you get one wrong, here we go. Every time you get one wrong, I'm going to take this book and smash you on the head. Every time Jennifer gets one wrong, I'm going to take one and smash her on the head. And then, if her head starts to hurt too much, I'm going to take it and smash her on the shoulder. Right? Now, if you ask me why you're going to do that, I have to have an answer that says, I have a theory of learning that tells me inflicting physical pain on people is a good way to get them to learn. And here's the research to show it. By the way, it's not. Okay? It's terrible. Okay? You understand what I'm saying here? And we do, and theoretically, you ought to have a reason why you're going into practice and why you're doing what you're doing. And this ought to come from some attempt of what your theory of what schools are about, how kids learn effectively, and what kids are trying to do, right? I'll give you an example with homework, for instance. Okay? There are some psychologists who believe learning has to be immediate. Skinner's one. Skinner said, here's what I think about homework. If you take the homework home and the kid gets it right, right? The kid doesn't know if it's right until the next day or 2 days later if the teacher bothers to go over it and then he gives it back. Okay? So it doesn't help. The kid has to know right away. Not only that, if the kid doesn't know what's happening, the kid gets it wrong, all you have to do is have the kid practice doing something wrong. So homework's a bad idea. You have to give the kids instant feedback, what you call reinforcement, right away. And if they get it wrong, you got to stop doing it immediately and back up. Okay? Not everybody agrees with that. Okay? And you have to constantly be thinking, why am I doing what I'm doing? Let me give you one of my grand examples. We're taking a vote, you have to vote. How many people here think that giving kids grades is a good idea? Grades. Got an A, a B, a C. Who thinks that's a good idea? Who thinks it's not a good idea? Holy mackerel. What's happening here? Don't tell me I'll be darned. All right. No kidding. It looks like slightly more than half the people, at least who are sitting here, said no. Okay. Though someone who thought that grades are a good idea, somebody tell me why. How many people think it's a good idea to give people grades and send them home to their parents, that their parents should see the grades? Who thinks that's a good idea? In other words, you think you can give kids grades, but you can't let their parents know. Or if you give the kids grades, the parents ought to know. Who thinks it's a good idea? Why?
For the parents.
Wait. Go ahead.
For their parents to know
Know what?
the grades? No,
Why?
I'm asking you. Why should they know?
I mean, what does the grade tell the parent? Go ahead.
The progress of the child, to see where
the progress of the child,
where he started, and will it improve?
Okay, let's try this. I have a kid in my class. Let's say in the school where I am, C means it's average. Not bad, not good, average. I have a kid who comes in, who was in my class, does average on tests, average on quizzes, has some class participation, other times doesn't participate. Well, it's about average. Homework, I give homework, it's about average. Classwork, about average. Average. Everything's about average. What grade would you give the kid? A C, right? That's average. Okay? Now I have another kid. Very, very weak. The tests are not very good. Matter of fact, fails a lot of them. Quizzes really bad. By the way, the other kid, the first kid, the homework is in 90% of the time. Most of the time it's not in. Some 10% of the time it's not in, or it's done sloppily. But this kid's homework is done, and you can tell tried very, very hard. It's clear the parents are helping, but it doesn't matter because the kid really, slowly the kid is making progress, works very hard on the homework. Constantly asked to do extra credit stuff. Tries very, participates all the time, asks questions. Is trying her hardest. By the way, I have to tell you about his and her. I'm sorry to interrupt it, but I didn't at the beginning. Political movements come and go. They make their effect in America good. When I was in school, you always said his. The kid is trying his hardest. You always use masculine pronouns. The feminist movement came along and said, discrimination. Can't do that. Okay. But we got into this mess. His, her, everybody did his work, everybody did their work. Everybody did he, she, he dash she, right? And then we got grammar mistakes. This will be on the test. Each child is in their seat. That's wrong. Each child is singular, in his seat or in her seat. So now you have to say each child is in their seat is wrong. And there'll be a question about that on the test, I promise you. Everybody did their work? No, everybody did his work, or everybody did her work. Everybody is in the classroom. Everybody is singular. Everybody, every single, right? Everybody did her work or his work. How you do it on your test, I don't care. If you want to say everybody did his work, it's fine with me. Everybody did her work, fine with me. Everybody did his/her work, is fine with me. But his/her messes up the English language. He dash she, don't write in singular, write in plural. So here's how I do. One day I'm reading a book, and the author is using all feminine pronouns. Each child did her best, nonetheless, right? Then I go to the second chapter, and it says, every child, when put in his proper environment, well, and he has a little star down there. He said, I draw the line at messing up the English language. So in odd number of chapters, I'm using feminine pronouns. On even number of chapters, I'm using masculine pronouns. That's my system. Odd numbered days, I use feminine pronouns. Even numbered days, I use masculine pronouns. So those of you who are watching on tape, you will know if I'm using masculine pronouns, it was an even numbered day. Feminine pronouns, it was an odd numbered day. One day I had a guy, he's outside my class. He has a pencil and he has a postcard stapled to it. And he's protest. He says, this is my picket sign. I said, what's the matter? He said, last week was the 31st. This week is the 7th. You're using feminine pronouns twice in a row? Discrimination against males. Okay? I mean, he was obviously kidding, right? So that's what I'm going to do. Okay, so we have the second child, and today's an odd number day, so she tries very hard. She does her best. Her homework's excellent. She participates in class. Her homework, but her test, she's very, very weak. She doesn't know the subject well at all. What grade would you give her? Who'd give her a C? She's doing her best. The homework's in on time. She gets extra credit. She tries hard. Would anybody give her a C?
I would, because if she needs extra help, she needs to know that she needs to get extra help so that when she grows up, she knows the subject.
Okay, we wouldn't give her an F. Who'd give her an F? She flunked. I mean, she doesn't know this stuff. Okay, let's try. What grade would you give her? We're taking a vote. Who'd give her an A? You have to give a grade. Who'd give her a B? A B. A B. Who'd give her a C? Who'd give her a D? Who'd give her an F? She was B, C had the most. There were B's and D's. Okay, third child. This child is one of the most brilliant children you have ever had in your class. You cannot believe it. Right? Give her tests. The lowest grade she ever got was a 98. Pop quizzes, you don't even talk about? Hundreds. Right? You gave her a home... Never does her homework. Never does her homework. Never. Class participation, not interested. Extra credit, not interested. You gave a project to take home. Okay, you gave a project to take home. Okay? What was her home project? She handed in the project. It was the most brilliant thing you ever believed. You cannot believe a kid in whatever grade you're teaching could do something that magnificent. But it was 5 days late. What grade would you give her? C. Who'd give her a C? Okay? Who'd give her an A? One person. You give her an A too? Who'd give her a B? She never did any homework. Everything comes in late. You still give her a B? Who'd give her a C? Who'd give her a D? Who'd give her an F? Nobody give her an F? She never did one homework assignment. Okay. Here we had the for C. So who would have given C to all three kids? Okay. So now I'm a parent. I open it up, and there's a C. Oh, this means my kid is the weakest kid in the class. Or it could mean my kid is average, or it could mean my kid is the most brilliant kid in the class. Why am I doing that? Some people gave a B to the second kid and a C to the first kid. So my kid got a B and is much weaker than the kid who got a C. Doesn't really understand the stuff. Only 3 people gave an A to the most brilliant child that you've ever taught. 2 people. Me too. Yeah, go ahead.
Wait, is it working? Okay.
Yeah.
You said that you give a C to the weakest child, and then the average child, and the most brilliant child.
Some people here gave a C. Most people would give a C to all 3 kids.
But brilliant in what area? Because obviously the child that's brilliant, like intellectually, has a weakness in not being able to turn in paper late. So how?
But if I take all this stuff and mush it together, that C tells me nothing. For all I know, my kid is the most brilliant child and has a problem with handing in homework. Or my kid is very responsible, hands in the homework, does all the stuff, and just doesn't know anything. I don't know any. I mean, it doesn't give me any information. Go ahead.
Well, then, if you show the parent the C, then they should be more involved and say, why did you get this C? Is it because you don't understand, or are you just not doing anything?
Okay, so the question becomes, but why do it? Why say, look, I'm going to give you something that means, a grade that means absolutely nothing. It means nothing. You have no idea where your kid's strong, where your kid's weak. you're going to have to figure out what this meaningless grade means. So what do we do in the first place? And all of you know that that's my suspicion of why there are SATs. Because colleges say, I don't really know what these grades mean. Just get a C average and got 3 700s on the SAT. Maybe we'll take a risk. Another hand, go ahead. By the way, a lot of time and energy is spent averaging these grades. Go ahead.
I went to school in New York, so...
Where in New York?
Long Island. And
by the way, there are two kinds of people in New York. Those who grow up in the greater New York City area, people who call New York City the city, like there's no other city in New York. And those of us who come from the rest of New York, who know there are other cities like the one I grew up in, Rochester, right?
Well, I'm from the Brooklyn part, so...
What?
I'm from the Brooklyn part.
Oh, my God, even worse. Go ahead.
Okay. And when I went to the school out in Long Island, we got our grade, but we also got a comment. Like, even if we got a B, it would
say... So why
say,
not just have the comment? Why bother with all the time with a grade?
Because you have to measure against the other students in your class.
Why? So measuring what?
Because in the beginning in the beginning of the class, each teacher would always say, "This is what you need to do to get an A." So every student would have to do that. So you have to measure it against that.
But I don't know what my kid did and didn't do. By the way, that's another way you know. The rest of us from the good part of New York State call it Long Island, and the people from the greater New York area call it Long Island. You heard how she said it, right? All right. New York has rivers. It has forests. It has beautiful lakes. It has farms. It's not all that mess in New York City, right? It's a beautiful state. Anyway, I understand, but why does the teacher say that? Why does the teacher say, this is what you have to do to get an A, and if you get a B or a C, it will tell me, your parents, absolutely nothing about what you're doing strong and what you're doing weak. Just to give you an idea, okay? So things ought to make sense. Anybody else want to argue with me about this? Let me just do this because we're running out of time. Let's go back to the PowerPoint. The assumptions that a lot of you were making is the school. Come back to me for 1 second. Come back to me for 1 second. The assumption that was just made that a lot of you made is the purpose of grades is to sort kids along some sort of a spectrum, from the best to the worst, high, low. That this is a super important job of schools, sorting kids from top to bottom. Okay? A lot of people say that should not be the purpose of schools, to sort kids. So the assumptions you make determine the practice of which that's a sociological assumption and a psychological assumption. I have to tell kids how good you are based upon your willingness to conform to the system. Okay? But we also have psychological assumptions. Now let's go back to the PowerPoint. The assumptions you make about people have a profound effect on the kinds of research psychologists do and the kinds of educational practices that they say you should do. And every educational practice in which you engage, hopefully, many of them come from no research at all, they should reflect your idea of how kids think and learn. And because of the differing assumptions that theories present, okay, we don't have our Newton. We're still with different people. Newton, who made a comprehensive theory of the universe, we have different people making different assumptions. They present various pictures of what human beings are. And they have differing assumptions about the basic nature of people, nature in quotes, okay, because psychologists don't like the term human nature. Okay? So for each theory has to ask, what educational goals are most consistent with this theory? What should be the purpose of schools and education? What educational methodologies are most consistent with this theory? We can't do this for every theory, but this is what you should have in mind. How does the theory define achievement? What are the factors that contribute to achievement? How do we get kids to achieve? What are the factors that contribute to lack of achievement, possibly causing a kid to be labeled? Okay? Okay, that's enough. Come back to me. Okay? So, if a theory is going to say the purpose of schools is to make kids mentally healthy, I'm going to have a very different school from one that says the purpose of kids is to learn basic knowledge. which in turn is going to be a very different school from when it says the purpose of schools is to help kids think. If I have a school that says the purpose of schools is to grade kids and sort them along some sort of a spectrum, that's going to be a very different school from one that says each kid is different and each kid ought to achieve. I'm going to judge each kid against herself. Okay, when it's really important, I have to use both, or himself. Okay? And let me warn you, quote unquote the word warn, there are some things that go on in schools that no psychologist would agree with. There is no psychological theory that wouldn't be horrified by saying we're going to teach all the kids the same stuff at the same pace and give them a standardized test on the same day. All psychological theories would say, oh my God, what are you doing? Okay? You know what I'm talking about, the Tacky Test, right? And some would say you could probably get the kids to pass all the tests, a lot of the kids to pass the tests, but I'm not so sure they're going to be learning much of anything, and there's a lot of evidence that that's true. They know how to pass the test, not much else. Go ahead.
I thought the testing was not the school's choice, it was a state-mandated test.
What?
The Tacky Test. Isn't that
the tax test? Yeah.
It's state-mandated.
It is.
So
it is. I'm not saying it all happens in the schools. We have educational practice that goes through the state, even the federal government now. Right? You go, if you go to the education building in Washington, I was just there, my son lives there, there's a big sign in the front, no child left behind. It probably costs $10,000 of your tax dollars to put it up there. As one of my friends said, before you decide whether or not you want your kid left behind, whether you ought to find out where they're going. Right? If you don't like where they're going, maybe you want your kid left behind, okay? So, you have to be careful about this. And you have to ask yourself always. I mean, I'm not blaming on individuals. You know, that's a good question. Let me put it this way. In the end, you're going to see what I want is for teachers to be subversives. Because I still believe in my heart of hearts, when the teacher closes that door, that she or he can make a difference. Can make a difference. Okay? That even though at this given point, phonics is the God, it was decreed by God, right? And then the next day then 5 years later, this whole language is decreed by God. That the teacher can say, you know what, especially if you get experience, I'll slip in a little of the other stuff because the kid isn't learning this way. Okay? Eventually I'll tell you, I know the answer. I'll tell you later in the course. The best way to teach math, the best way to teach science, the best way to teach reading to kids, I know the answer to all of those questions, but I'll give them to you later. Okay, so in the end, we're going to look at these theories, see what kinds of educational practices they mandate, and what they think is important to learn. Is memorizing important? Some theories say yes, some say no. Is this important? Is that important? Okay, so next week, we're going to start on our first theory, which I believe is learning theory, right? Okay, and we'll go from there. See you then.